We are trying to look at these notes, concept of an electric field. So that is what we are going to look today. So, well, life is a very beautiful phenomenon. It has now many strange, mysterious forces. Now, there are contact forces which require contact, and then there are non-contact forces like magnetic force, gravitational force, and so is the one we are going to look, the electric force. Now, when we are trying to explain these non-contact forces, we need a way of looking at it, a way of modeling the thing, so that we can understand how these forces are able to act even at a distance, right? So we want to look at how these forces are able to act at a distance. Now, a model, so this is a model in physics means a way of looking at things. It's not actually there. It's something that you can use to understand what's happening. What's happening is abstract, invisible, but the model helps you to understand what's happening. For example, our forearm, okay, the forearm and our arm, our hands can be modeled like two rods connected, and there is a weight acting, and then you can use the idea of a rope connecting it and a tension acting on it. So you can model this thing like this. This is a way of modeling this. Similarly, the concept of a field, an electric field, or any field for that matter, whether it's an electric field or a gravitational field or magnetic field, is a way of explaining, a way of modeling these non-contact forces. So we define electric field. So this you should be able to explain or write what if you're asked to define what is an electric field. The definition goes like this: an electric field is a region of space. So it is a region of space where a stationary positive charge experiences a force. Now, for the time being, forget about the term positive. So, electric field means it is a region of space where a stationary charge experiences a force, right? Now, so it's basically they're saying that if in this region there is a charge and that charge is going to experience a force, then that region, that space is considered as a field, right? You can think of it like this. If you're asked to define a football field, you can define it like this. It is a football field is a region of space. A football field is a region of space where football would experience a force, right? As long as the football is outside the field, like in the room or in the pavilion, nobody is going to play with it, nobody is going to hit, assuming that they are not like you, okay, they are proper audience. Nobody is going to play with the football unless the football is in the field. The field is there for the football to be played with. So the football field can be defined as a region where the football is going to experience a force. Similarly, an electric field is a region where if you put a charge there, it's going to experience a force. Now, that is the basic understanding, but when you're defining it, you should add the words stationary, because a moving charge creates some magnetic field, and that in the magnetic field and electric field has a close relationship. So just to avoid all that confusion and chaos, we define it as a stationary charge. We ask the charge be still, okay, for the time being. And we define it as a positive charge because this electric field is talking about force, right? We are saying that it is a region in which a force is going to be experienced. So when you are talking about force, the direction is taken into account. Now definitely the direction in which a positive charge would experience a force is going to be diametrically opposite to the direction in which the negative charge would experience a force. So just to take into account and make the definition or the standard very clear, we also add the term positive. Okay, so the fundamental concept is an electric field is where a charge is going to experience a force. But when we are defining it, we go ahead and add further the two terms stationary and positive. Okay, so an electric field is a region of space where a stationary positive charge experiences a force. It is similar to a gravitational field where a gravitational field is a region of space where a mass would experience a force. A magnetic field is a region of space where magnetic pole is magnetic north pole. Again, there also we try to define it in terms of north pole and not south pole, just like here we are trying to define it in positive, not in terms of negative. So magnetic field is a region of space where a north pole would experience a force. A devotional field is a region of space where a disciple would experience a force in the presence of a master. So just the idea, okay. Or a romantic field is a region of space where a boy would experience a force of attraction. And why we choose boy? Well, it is not male chauvinism, it is simply just like why we chose positive, and from positive and negative, why did we choose positive, right? So just like I chose boy, I'm not saying boy is positive and girl is negative, in fact we can have it the other way. So well, the basic idea is that it's a region of space where a charge is going to experience a force. Now when we're talking about the gravitational field, this confusion of choosing one over the other, choosing positive over the negative or the north pole over the south pole, didn't arise because there was only one thing. There is no positive mass and negative mass, and the force is always going to be towards, right? It's always going to be an attractive force. But in the other two fields, there is also the possibility of repulsion.